Okay, thank you very much. So based on some information which has been collected for other talks, I would like to show you a couple of examples. So with respect to digital technologies in process industry or in manufacturing in more general. And so where we had a starting point, so when we discussed this presentation, so why emails in the beginning, so Mike had a similar statement as in the beginning. You're doing something wrong? That it's indicated that process industry is lagging behind so in the adoption of Industry 4.0 concepts. And so that ARC is attempting here to identify and communicate the challenges. And so my first impression was, without this being an offend, is that this is kind of the position you should have if you're a consultant, if you're a vendor, or if you're leading a digitization organization. And at least I think there are good things on the way, and there I would like to show and share some examples with you. This slide is kind of the agenda for the talk, and at the same time it's also the thesis and the summary at once. So because I would say it is true that process industry has specific challenges, so which makes it harder to implement Industry 4.0 use cases, but nevertheless, I think if we have things which are addressing our value drivers well, and those value drivers are different to the typical showcases coming from discrete industries. So there are good examples of this being implemented also at larger scales already. And I would share some thoughts only with you is that up to now, I would not see really a mass effect of those digitization technologies independent of the industry, but maybe we can discuss this later. Okay, let's start with the requirements. So first of all, so what came in my mind was, of course, the explosion protection. That you have a limited energy closer to the process, which means it will somehow limit the degree of edge devices intelligence you will bring closer to the process. So that's simply a barrier there, and you might be forced to take different concepts than other industry might use in this case. Then next is around process, machine, and product safety. So the safety systems, everything which is going along with qualification of processes in terms of GMP, etc. So that will be a hurdle to any change you want to make to processes in that case. Then we have the very long life cycles and a resulting conflict between IT innovation cycles and the plant life cycles, that you need a high degree of interoperability and connectivity, and that you can make those solutions work throughout your entire asset base. A high diversity of processes often, so the broader your company is operating on the value chain, the worse this is. So it might go, so for BASF, for example, it starts with the steam cracker, so which is a petrochemical plant with availability over everything else, a lot of energy and raw material consumption. And it goes down to very customer-focused, centric businesses with a lot of raw material handling, where then work efficiency suddenly starts to get the key lever. And last but not least, high availability demands in many cases, and that will limit the degree of trial and error you can do on those plants. And therefore, concepts like open architectures are also necessary to containerize solutions well, so that you can try and implement new solutions without harming your continuity of the core systems. Regarding the value drivers, this was, in my opinion, very well stated also yesterday morning by Praxair, is that a lot of use cases are focused around work efficiency. So paperless production, etc., no double work. And simply, so this is not meant to be complete. I've just in Wikipedia copied some numbers for employees and revenues per year for different companies, so which came to my mind. If you would start with engineering companies, basically the revenues per year divided by the employee would be around 100,000 euros. So that means everywhere you get more efficient directly has a very high impact on your earnings of the company. Then companies like ABB and Siemens, so this is around 250. So still work efficiency is very important. Then here in the mid-range, so like BASF or Covestro, it goes up to 640,000 or already 1 million revenues per employee. So here you can already see that Covestro is more focused on the commodities, and here we have the share of the more work-intensive downstream productions, and companies like ExxonMobil, you go up to like 3 million revenues per employee. And that means somehow if you look at these parts of the value chain, so energy, raw material, efficiency are key factors. And of course, in all those, safety, etc., is above all. And these are then the key value drivers also to be addressed by the use cases, which I will show you in a second. Okay, did I get those from? Luckily, in November, there was a presentation on digital 4.0 technologies and process industries. That was a joint presentation by BASF and Bayer at that time. And there had been a survey to all companies to contribute with use cases. And therefore, it was an easy choice to collect some of those to make life easier. Okay, what do we have here? So it started here with a promise from a more consultancy side. So what are the overall arching targets here? Like a high reduction of total machine downtime, 30 to 50% might be ambitious. Yeah? And reduction of material costs, 10 to 40% might be also ambitious. And here, for example, we have something Sanofi has contributed. I've put the link in YouTube, so there's also a nice video on this. So Sanofi has launched a 4.7 billion euro invest regarding the plant of the future. And here you can see some of the targets, which are also very asset-centric, so around also faculty size, number of controlled instruments, etc. So, and this goes very much also into how the production is running of those pharmaceutical products. Then here, two use cases on the left side from Source Evonik. Also, you have that in other companies. We do have that as well. It's around mobile maintenance. So equipping workers with tablets, having some kind of an augmented reality so that you can have the devices are recognized by the camera and that you can have then the process data directly at site of the location. Or here is an initiative we are driving in BASF is around a digital shield for each and every asset so that you have consistent information for operators, for maintenance, for turnaround, and for technical materials management. So also with a QR code here. And if you think about challenges, so here it's, for example, already the number of vendors you need to convince to work according to such a standard. Here two things with short videos. So on the left side, this is a drone which is performing wall thickness measurements on a tank. So I think that is a very valid use case for everyone who has corrosive materials inside tanks and pipes. And getting better here than having regular inspections going there is of course good. Also, these solutions nowadays have typical limitations. For example, the battery time is in the range of seconds and then the drone needs to go down. Nowadays, it can only move vertically for some reason and not horizontally. But here you can really think if that solution becomes available on a broader scale, that this is something which is very nice to use because it's something which needs to be done on a large scale. It has safety impacts, etc. And it really eases the life. On the right-hand side, this is around work safety. We also have a pilot right now running in Germany in our facilities, so that a worker entering a certain area is automatically checked by image processing if he has the right protective wear on. Further examples here around predictive maintenance. For example, on the left side, that was a joint product and CDAP to make advancements in terms of valve diagnostics so that you can easily early detect errors of valves. With those cases, then the economic justification kicks somehow in because you have a lot of valves and probably all of us have not too many critical breakdowns of valves. And then you need to be effectively and efficiently be able to monitor all these, and this really comes down to cost. If you want to monitor all, it needs to be cheap in the end. On the right-hand side, an example from ThyssenKrupp, large-scale monitoring of cells in chlorine facilities, directly then addressing your asset cost. So again, you can think that this is very much in the interest of the operator. Use case which we have performed together with ABB around pump monitoring with vibrational sensors, then sending out vibrational data out. And this is, since I know the example a little bit also, so this is kind of straightforward that you do vibration monitoring on pumps. But then in the end, The question is, what do you do with it? Now you have abnormalities. You might send someone there. Do you take it out then? You need to integrate that in all your work process in the end. And this is then the whole change then of the workforce, work processes, etc. So this is then kind of the hard part compared to the drones, where you simply, if you have it, you can implement it and have it run. Two more examples might be also familiar to you, like fouling of heat exchangers, so monitoring of the heat balance. Here, often sensors are a problem because your heat exchangers might not be equipped with the respective sensors so that you could directly measure the heat transport out of it by closing the heat balance. On the right side, what we have also shown in different occasions, this directly addresses the work processes. We have launched the so-called reliability center, so where all critical equipment is now onboarded as a central service where people are centrally monitoring this and providing services for reliability to the company globally. And here for additive manufacturing, I have a small video which can then save my own speaking resources for a moment if you would have the tone.
Friday, 9 a.m. After a malfunction report at a BASF plant, both the asset manager and maintenance manager meet at the affected part. But neither is an expert on this particular system. A perfect showcase scenario for advanced technologies in maintenance. To avoid expensive downtimes, they need to get all necessary information as fast as possible. Using the HoloLens, they can instantly get in contact with a designated expert for this machine who can provide relevant know-how and detailed documents without any delay worldwide. Another challenge in maintenance is that an urgently needed spare part often cannot be delivered in time. Therefore, BASF utilizes 3D scanning to produce an exact copy of this piece within a few hours. But that's just the beginning. After the reconstruction is made, engineers analyze the part and its functionality within the chemical process and optimize the design according to these needs. Of course, not without discussing all changes with the internal partner, again, using advanced technologies. And it doesn't stop there. With today's technology, many parts can be produced by 3D printing. Compared to traditional manufacturing methods, 3D printing gives a whole new freedom in design and allows the introduction of additional functionalities inside a part. Additive manufacturing has many benefits: process efficiency, faster delivery time, and rapid prototyping, as well as reduction of maintenance time and an increased lifespan of the parts.
BASF. We create chemistry.
So this is certainly also, I'm not even sure if you would see that as a digitization use case, so using those additive manufacturing aspects, but so it's very much at the core of the process, and the closer it gets into the interests of the owner-operators of the plant, the better and the more accepted those things get. Then a couple of thoughts, if there is already a large-scale effect or not. So since 2011, this graphic is around in this format or others, that with the digital solutions we get the 4.0 in the end should mean that we get a fourth industrial revolution comparable to the introduction of robots and PLCs or conveyor belts. And actually, such an industrial revolution should show up as kind of jump in the change of the GDP, defined as the gross domestic product per employee or per hour worked. And then I did a quick Google search, not an academic study, so how this should look like. And I had the productivity change of Germany here first, and which tended to be around 2 to 3%, also here with 2008, 2009, the bank crisis. And then the question was, okay, what happened here after 2011? So after that was the fourth industrial revolution was proclaimed already. And such charts you might have also seen. So this is, for example, the data volume per connection, again with a focus on Germany, so with this exponential rise, starting around really 2011. And then if you look what happened to the productivity changes, actually you do not really see anything happening here. So a lot probably was higher resolution videos and video streaming, so which contributed to those data, which was not immediately turned into higher productivity. Of course, there are other effects like political effects, like interest rates, etc., so which influence that, but at least there is no massive disruption being visible. And this is also true then for Europe or the US in total. So looking here at the productivity changes, so nothing spectacular happens then going here in the direction of the presence. This is much different. So if you look here, for example, after the Second World War, you reach productivity rates of 6, 7%, or also here then before that. So that should be here the first introduction of automation, for example. But nevertheless, I think there are good examples on the way. I would not want to stop too pessimistically on this. For example, I've just picked one example, so which are automatic guided vehicles, which we now have on site for logistics of material on site, or the whole topic around autonomous driving. I would think so if that would kick in on a larger scale, then we should actually also see that in the productivity changes of society. Okay, so then I would like to conclude. Basically, that was the content of the talk. And also what I would like to remind you is that there are always digital and non-digital concepts on the horizon. So if a digital concept is not being implemented into a plant, even though it might have a positive value contribution, it might simply be that there are other concepts which are even more promising. Because things like reactor technology or catalyst technology, these do not stop. And each and every company has limited resources in terms of budget, but often mostly in terms of personnel. So on how many topics a plant manager can focus, and it might not always be the digital topics he chooses first to be implemented. Okay, thank you very much.